Welcome to the review of arc sectors, part 1. We're going to do both reviews today and see how you guys do. And then hopefully, by the end of this, you understand everything we're doing fully. Now, the goal of today is to find the circumference of circles, find the area of circles, find the arc lengths and the area sectors of circles, and also find the area of regular figures that involve circles and some regular polygons. So here we go. First thing you're going to do is find the area and circumference of each of these 6 circles. Go. All right. As you guys should know, area is pi r squared, circumference is 2 pi r. So in order to find, since you're given the radius, pi 23 squared, 1661.9. All right. In order to find the circumference, 2 times pi times 23 is just 46 pi or 144.5. Good. Now, when you're given the diameter, you have to convert diameter to radius in order to find the area. So to do that, you just divide it by 2. So half of 12 is indeed 6. So now you just plug into the regular equations. Pi 6 squared is 36 pi or 113.1. For circumference, you can use either pi d, you can use 12 pi, or you can still, since you have the radius, 2 pi r. 2 times 6 is 12 pi, which is 37.7. Good. Problem number 3. 5, since you're going from the center to the outside, that is indeed your radius. Pi 5 squared is 25 pi r, 78.5. Circumference, 2 times 5 is 10 pi, or 31.4. Hopefully you're doing well. 15 goes straight across the whole entire thing. Circle through the center, that means it's the diameter, so you have to find half of that. Half of 15 is 7.5. Yes, decimals are okay. All right, don't get scared if you get a decimal. Pi 7.5 squared is 176.7. Now, you can use either pi 15 or 2 times pi times 7.5 if you just want to use the 2 same equations the whole time. And you should have gotten 47.1. These are the easy ones, so hopefully you're getting all these right. Pi 34 squared is 3,631.7. 2 times 34 is 68 pi, or 213.6. Just round everything to the 10th place. It's better than whole numbers. 19. Pi times 19 squared, right? 1,134.1. And then 2 pi 19 is 38 pi, or 119.4. So hopefully you got all 6 of these right. Now we're going to get into a couple more difficult problems. Now these problems are involving finding the arc length. Now, I want you guys to attempt problems 7 through 12. Do you remember the formula? If you don't, the formula is the measure of the central angle, or whatever angle you're finding the arc of, over 360, that gives you the percent of the circle, times the circumference, which is 2 pi radius. All right? Or times pi d. We'll just stick with this one right here. Makes it the same, makes it uniform every time. So we're trying to find the arc length right here, AB. It is 104, right? So what do we do? What do we do? We put 104 over 360. 2 times pi times 21. Got it? Not very difficult. Plug it on your calculator. 104 divided by 36 times 2, pi button 21, and you should get 38.1 as an answer. All right? Here, this angle right here is what? Perpendicular, so it's 90 degrees. So we're finding AB again, 90 over 360, 24, 2 pi, 37.7. Right here, we're looking for AB. Make sure you look to see what you're looking for. That way you don't look for the wrong thing. So AB is the minor arc. Okay, remember, if you're given 2 letters, it has to be the one that's under 180 degrees. 18 over 360 times 2 pi, 100 is our radius, and you should have got 31.4. 3 very simple problems. Problem number 10 over here. Radius, central angle, AB's, this is AC, so we're not using the 136. We're looking for ABC, A to B to C. So, do you guys remember how to find that? Yell it out. How do you find it? Good. You you subtract 136 from 360. And you should get 224 as an answer. So now you take your 224 over 360 times 2 pi 39. Gives your answer, and you should get 152.5. All right? A little tricky. 11 is a little tricky too. You're just given a straight line of diameter across, and you're just given that diameter is 50. Now, Semicircles. How many degrees is that? How many degrees? 180, right? And to find the radius, half of 50 is 25. So 180 degrees over 360 times 2 pi, 25, or just pi times 50, should give you 78.5. Now, if I went AC the other way, guess what? The answer would be the same, all right? 12. Oh, this gives you a bunch of stuff. So first thing you're doing is you're finding AB, not 42. Now this is 180, so you have to do 180 minus 42 to get the measure of AB. So that gives you 138. So once you get 138 here, now I need the radius. Since this is the diameter and it's 88, you do half of 88, which is 44. 138 divided by 36 times 2 pi 44. 106 is your answer. All right? And that is finding the arc plane. Hopefully you guys did well and got all those answers. Now, we're going to take it up a different level and we're going to find the sector area. Now, sector area, the area of the shaded portions of these circles. All right, now, formula for this, same as before, the measure the central angle, the measure of the arc over 360 times, now instead of circumference, it's pi r squared. It's times the area. So this one right here, we're going to set up our equation. The measure of the central angle, that's 90 degrees, right? Radius here is 24. 90 divided by 360 times pi 24 squared. And that gives you 452.4 as an answer. That's not very difficult. All right, let's try 14. Semicircle. Semicircle means half a circle, so that's 180. All right, 33 is your diameter. So you need half of 33, which is 16.5. 180 divided by 360 times pi, 16.5 squared. And that gives you 427.6 as an answer. Hopefully got all these right here. And if you need to adjust your answers, just pause it, adjust your answers, and try again. 34 is our central angle, 142 squared. Pretty much just plug it right in, 5,982.8. Here, we have two shaded portions. Now, since this is 101, what's this angle right here? It's also 101 because they are, what kind of angles? Vertical angles, and vertical angles are equal. So the total shaded portion here is 101, 101 is 202. So when you do shaded portions, just add up all the central angles and divide it by 360. 202 divided by 360 times pi 10 squared gives you 176.3. If you found each one of these individually, did 101 over 360 times this, plus 101 over 360 times this, you would get 88.15 plus 88.15, and you'd get the same answer. This is a little less work, though. Just add them together. Much easier. Right here, 52 is not the shaded part. Once again, 180 right here. So 180 minus 52 gives us 128 as our central angle. This whole thing is 20, so we need the radius, which is half of 20, which is 10. 128 over 360 times pi 10 squared, and it gives you 111.7 as an answer. Are we good? Hopefully we are. 18. This one gives you some trouble. There are no numbers, just a diameter. What do you notice here? I notice, look at your, think. Watch this. These two, these A's, I'm just giving a letter. These two sections are the same, right? And what about these? They're the same. All right, so A plus B equals B plus A. So how much of the circle shaded? Half. So half the circle shaded, and then find the radius, half of the diameter, you get 162. So you just do half. You don't have to do 180 over 360. Half of our circle shaded times pi, 162 squared, and you get 41,224.0 as an answer. That is sector area. All right, let's move on to 3 irregular figures, and then we're done with the first part, and then we'll do the second part right back to back. Don't cry that you haven't done this before, but it's still pretty easy. Find the area of the shaded region. Notice my shaded region is the region around the circle. So what shape do you notice is around the circle? Okay, square. And the area of a square is length times width. All right, so 100 times 100. Now the reason we know these are both 100 is circles have the same diameter both ways. So if the diameter is horizontal, it would be the same as the diameter vertically. All right, so the area of that problem is 100 times 100, or 10,000. So that's the area of this whole entire circle. But what's inside the circle? I'm sorry, the area of the whole entire square. Inside the square is a circle. So can we find the area of that circle? Of course we can. Half the radius. Radius is half the diameter, so the radius is 50. Pi 50 squared gives us the area of this white circle. So pi 50 squared is 7,854. What do we do with these two numbers to find this piece of here? Well, just think in your brain. Is the area of this stuff greater than or less than 10,000? Obviously, it's less than 10,000 because you had 10,000 here, and you're taking out this inside part. Since it's less, we take these two numbers and we indeed subtract them. Anytime you take something out, you subtract. You subtract the two numbers and you get 2,146. All right? Just take it up a little bit. Number 20. Ooh, you guys get this one? Well, what you should do here is split it into two pieces. You got a square and you got a half of a circle or a semicircle. So the square, this is exactly half of one circle. Now, square is easy, length times width, because it's a rectangle as well. 10 times 10 is 100. Now, how do we find the area of that green piece? Well, if the diameter is 10, what's the radius? Half of 10, which is 5. So we could take the area of this and do what with it? Half of that. So it'd be half, because half of a circle, of pi r squared. So it'd be 39.3. Now, do we add these numbers or subtract these numbers? What do you think? Is the total area going to be bigger or smaller than this purple piece? Obviously, it's bigger because you're adding that piece on top. So you add the two. And your answer should have been 139.3. All right? Problem 21 was the toughest one. Let's see who got that. Did you break it up right? If you broke it up, it should look something like this. You have a rectangle, 3 semicircles, and a big semicircle. So first thing, can we find out these 3 congruent semicircles, what the radius is of them? Well, there's 3 of them. So that means 14 is each one of these. 14, 14, 14, right? So those are the diameters. So what's the radius of all these? Half of 14, which is 7. So since there's 1, 2, 3 semicircles, and a semicircle is half a circle, 3 times a half is 1, 2, 3. 3 times a half is pi r squared. 3 halves times pi times 49 gives you 230.9. That is the area of all 3 of those. Now, to find the area of this, since the whole thing is 20, half of 20 is 10. All right, still following? Good. So this is half of pi, 10 squared. All right, because the radius is half of 20, which is 10. Half pi 10 squared equals 157.1. So now we have the areas of these pieces and these pieces. Area of the rectangle is just length times width, 20 times 42, 840. Now what do you think? Do we add these or subtract these? Well, since you're not taking anything out, you're just adding pieces to it. It's addition, this plus this plus this. Add them all together, and you get 1,228 as an answer. All right, so that's the first quick review. Hopefully you guys did well. And now we can try the second one to make sure you really get this stuff. All right, so second review, same thing, and same basic concept. All right, so once again, we're finding everything the same exact thing, just different numbers for different problems. All right, so once again, find the area of circumference of this. Practice makes you guys really good at this tip. So I'm just going to go through these problems, do the whole packet right now, and then I'll just go over it at the end, or pause me and go. So first thing, radius, pi times 10 squared is 314.2. Circumference, 2 times pi times 10 is 20 pi, or 62.8. Diameter, have to take it in half in order to get the radius, and you get 31.5. Pi times 31.5 squared gives you 3,117.2. Pi times diameter, so it's 63 pi, or 2 times pi times 31.5. Both give you 197.9 as an answer. Go from numbers to picture. 19 is the diameter. Good, so we have to take half of the diameter, which is 9.5. Pi times 9.5 squared gives you 283.5 as an answer. Next thing, we need the circumference, so you can either do 19 pi or 2 times pi times 9.5, and you get 59.7 as an answer. We doing good? Awesome. Now, pi times 5 squared gives you 78.5. 2 pi 10 is 10 pi, or 31.4. Pi, 81 squared, gives you 20,612.0. 2 times pi times 81 is 162 pi, or 508.9. 63 is the diameter, so we have to do half of it. 31.5 pi times 31.5 squared. All right, 3,117.2. And then you got 63 pi, or 2 times pi times 31.5, and that gives you 197.9. All right? Hopefully you guys are masters. This is easy middle school stuff, so you should be. Find the arc length. So, first one is AB. Arc lengths are given to you, so find what they want. So, that's a 90-degree angle. Remember what we said before the formula was? Measure over 360 times 2 pi radius. Okay, so the measure here is 90 over 360 times 2 times pi times your radius, which is 14. Type it on your calculator and you get 22.0. Once again, round everything to the 10th place. Here we're trying to find AB. AB is given to you, which is 25. 25 over 360 times 2 pi 14 gives you 6.1 as an answer. Here, AB, given to you, the minor arc, 145 over 360 times 2 pi 6. And as an answer, you get 15.2. You guys are doing great. ABC is not 31. AC is 31. ABC is the part around it. So now you have to do a little work. The total angle in a circle is 360. So you subtract 31 from 360 and you get 329. So it's 329 over 360 times 2 pi 22, 126.3. Make sure you don't just take the small angle every time. Here, semicircle, which is 180 degrees. All right, half of 42 is 21. So you got 180 over 360 times 2 pi 21, which gives you 66.0 as an answer. Doing good? Awesome, awesome, awesome. AB, that's not the 77, it's the piece that's next to it. Remember, AC is the diameter, so that's 180. 180 minus 77 gives you 103 as your angle. Now, 36, half of 36 is indeed 18. 103 over 360 times 2 pi 18 gives you 32.4 as your final answer. Now let's go to area sector. Area, did bad. Oh, man. Measure over 360 times area. This is tricky. Not 90. This is 90, the unshaded part, so you have to do 360 minus 90. 360 minus 90 is 270. Divided by 360 times pi, 100 squared. And as an answer, you get 23,561.9. 120 divided by 360 times 2 times pi, 200 squared. 41,887.9. Half a circle, semicircle, right? 180 degrees, right? Or you can just do half. 180, half of 7, because that's your diameter, is 3.5. 180 over 360, pi 3.5 squared, 19.2. You guys are doing wonderful. 42. What's this angle? You just did it before. That angle is also 42. 42 times 2, or added to itself, is 84. 84 divided by 360 times pi, 6, which is your radius squared, gives you 26.4. All right. 165 is this. This is the part that's not 165. So 180 minus 165 gives you 15 degrees. 62 is the diameter. We need the radius. So half of 62 equals 31. 15 over 360 times pi 31 squared gives you 125.8 as an answer. A lot of stuff working on it. All right. We just did one like this. What portion of that circle is shaded? So let's match some things up. These guys match up. These guys match up, and these gals match up. So ABC equals ABC, so that means you have how much of the circle shaded? Exactly half. So now you also find your radius, which is half of 78, which is 39. So half of pi 39 squared gives you 2,389.2. All right. Hopefully you're doing well. Let's get these last three done. Problem 19. All right. What shape do you see there? You should see a rectangle with a semicircle on top. So, radius is half of 17, which is half of 4, which is 7. Area is 1/2 of pi r squared, 1/2 of pi 7 squared, which is 77.0. Area of the rectangle is length times width. 14 times 32 is 448. Are we taking this away or adding this? We are indeed adding it. So add them together, and you get 535 as an answer. Oh, that's a weird looking shape, right? I'll give you a hint. It's not two triangles. What do you think it is? It is a rectangle and a circle inside the rectangle. The radius equals of this rectangle, of the circle right here, half of 44, which is 22. All right, so it's actually like a half a square. So the radius is 22. Area of the circle is half of pi r squared, half of pi 22 squared, which is 760.3. That's this white portion. This gray portion is just length times width, 22 times 44, gives you 968. What do we do with these two numbers? Well, because we're taking the circle out, we're cutting it out, we subtract. And when you subtract, you get 261.7 as an answer. All right? Last one. That's a weird looking shape. Looks kind of like a cloud, doesn't it? Or that. Look at that. You got a rectangle, you got two semicircles, and you got one other semicircle. And what do you know? Two semicircles add up to one circle. So let's take this out. First thing we're going to do is we're going to take out the green one. Well, if the whole distance across is 10, the radius of this would be half of 10, which is 5. So, uh-oh, my numbers are wrong. Oh no, I never fixed this. 2 pi, 2 1/2, 3. All right, so this one's a little messed up here, but anyway. So this should just be 1/2 of pi 10 squared. So it should be half of 100 pi. So it should be 50 pi. So 50 times pi is approximately 155. All right, not 760. I'm not going back to fix that. So this one, half of 6 is 3. Pi 3 squared is 28.3. Now, you have two of them, and each one is half. That's how come the 2 and the half go away. And the last one is just 10 times 6. Right, 10 times 6 is 60. You add everything together. You should get approximately, oh, there we go, 127.3. All right, my answer is all messed up before. I'll go fix it, but since it's the last slide, I'm not going to change everything just for that. All right, so that is the review. Hopefully you guys do well in your review, and good luck on your test.